Okay, let's hope this works. I can see myself on YouTube now, live. And I will pull up the chat. And we can do this. Put the chat right up here. Okay. Now just to grab a stream link and share it. Copy video URL. Okay. And now I'll post on my Discord. Okay. Well, thanks guys for joining. Whoever's here. Hey, Space. Thanks for stopping in. So I decided I'm gonna tackle building a
back to game
CPU.
button.
Oh God! I just turned on narrator. Oh shit!
Game menu.
Oh
Give
no!
feedback button.
How the fuck do you turn this off? Turn off narrator. Oh God.
Yeah. When it says.
Why is that?
Options.
Oh my God, this is gonna be so painful.
Chat settings. Narrator. Off.
Oh my God. Okay. God damn. I don't know how. Oh my goodness. Yeah, I don't know how that happened, to be honest. Okay, chat, I'm gonna grab my coffee, and it'll take, oh yeah, I can turn up my mic volume. I'll do it through OBS. Is that better? Also, give me a second, I have coffee in the microwave that I was just about to grab. Alright. That's weird. Yeah, I don't really know what would be making that happen. I don't know if I press that button on my amplifier if that does anything more. I don't know what the air button does on my focus rate. I usually just leave the 48 volts on and crank up the gain on it, but I guess that's not loud enough either. I can go to my settings in OBS, go to audio. It's not letting me like change how, like there's no like sound, like loudness setting. Like there's down at the bottom in OBS I can properties. Oh, here I go. Okay, I can up the gain here. Found it. Alright, let me know when it starts getting too much. I'm at 3.5 decibels of gain. I'll go up to like maybe 6. Alright, there's 6 decibels of gain. Hopefully that's better. Hopefully I'm not too loud now. I'm working on a 2 Hz Minecraft CPU, and that means every stage, and it needs to be like 5 ticks or less. So if I end up getting more than 5 ticks in a stage, I'm just gonna have to pipeline it. So it might start getting overwhelming, so I might change the goal to maybe making it 6 ticks instead of 5 ticks, and then it'll be like 1.67 hertz instead of 2. But so some shit that Illusia was working on with me yesterday. If I got this counter that's counting up every 5 ticks. Whoop. I don't know why that's broken. Oh no. Oh, that's right, there's no signal strength reaching this shit. Huh. There we go. So the idea here is this is a counter counting up from, well, 0, 1, 2, 3, and it's triggering this. This is a decoder, and it's decoding one position in this wall at a time, or like one spot to send signal like down, and then it's encoding like in one wall. Like here's a register, and then it encodes data. Like this is then an encoder. So the idea here was to decode this binary value, bus it into an encoder that could then have like ROM. So you can have like a program counter counting through ROM addresses and then displaying the ROM content. So all it's doing is displaying 0, 1, 2, 3. And it's showing that this register here is making this like when this is 1, this is going to be 2. So this is always 1 count ahead of that. So the reason I have this register here is because if I'm pipelining it, and if this stage here was longer than 5 ticks, redstone ticks, then the decode stage could be, or the ROM loading stage could also be 5 ticks. So like it just split it up into 2 different sections. It's basically a pipeline register. But what I don't like about this design is how clunky it is. Like the decoder's kind of large. Well, it's not large, it's just messy. And you have to run this update line to it. And then on the register here you have to... Oh, dope. And then for the update line you have to like run this weird tricky mechanisms, and that means after 15 signal strength you still need a repeater to... Like you could use dust here, he said, but you would still need like a repeater after 15 to extend that to the next module. So it's nice though because it's 1 wide. But then I achieved the same thing now, except I don't have a hex counter that I could use yet. But with this hex input, this is a signal strength decoder with a 0 address. Not a lot of people put the 0 address in, but it's as simple as just doing that. So like if I wanted to encode data on the 0 address, it would be shown right now, so it would be like this. For instance, if I wanted to encode 2, but then if I go to the next address, 1, you saw it pulls that back and puts out the 1 address. So I can just encode different values on here depending on what's in the ROM. So I think this might be the more efficient way to do it, and then my program counter would have to be like a hex program counter where it would increment in hex and hopefully be able to load hex values in then. So that's one interesting thing over every other design I've ever done, and the reason I'm using these walls, for anybody who doesn't know, I know Space definitely knows if he's still here, is these walls can be stacked down to world height, and theoretically you could even get more density out of it by going like one like width here, like a piston every one, but then you need a way to get to do the wiring to get each signal out, so that becomes a pain in the butt. But yeah, theoretically this could stack like infinite bits if you could go through the world height. Yeah, so now what I need is Oh, what up, 4ED7FF? Interesting name, must be Hex. Well, it can't be Hex if there's FF. Oh no, yeah, it can. He's EF, yeah, duh, I'm dumb. F is 15, yeah. Yeah, thank you. Yeah, so now, I need to... Well, I don't know if I want to lay out the ISA yet, but I should stack this enough bits to get that out, like, enough for an ISA, so like maybe 64 bits and then cut it down from there. And then what I'll probably do is then I need to chain multiple of these together because this only holds 15 words of memory, and so if the memory words are huge, it sounds like a lot of memory. So if it's a 64-bit word and I have 15 or 16 of them, 16 times 64 is well, 16 times 64 bits is 8 bytes, so 16 times 8 it's like 512. So that'd be 512 bytes in just this little area going down, though. So it sounds like a lot of memory, but it would really only be it would only be 15 or 16 words. Oh, 4UD says, yeah, it's the hex color code. It's a really nice shade of blue. Oh, gotcha. Sweet. For his name. Okay, so now to stack this guy downwards. Oh, wait, I can squeeze one more width out of this. Okay. I think, wait, let me check. Maybe I just fucked up the inputs. Nope, okay, I just fucked up these, okay. Morning. Alright, so now I have one bit, so then I'd need to stack it 63, but then I already have another one, so now I just need to stack 62 if I wanted to say have 64 words. And did that go through the world? No, it did not. Awesome. That's pretty cool how freaking dense that ROM is going to be. Oh, I need to stack these down as well. And I have to close it off on this side as well. Okay, now this should definitely work, I hope. Alright, so if we do this, yep, push them all down. Cool. Alright, so now if the redstone block would go, well, whatever, if a redstone block was encoded and it gets pushed, it would go there, so then we need bust out like this. And since it's one wide and we have 15 or 16 of them, and I already have one bit there, or one of them there, I just need to stack it 15, and that gives us the width that we need. And then from here, since I have 63 of them, or 64, and I need to then stack it 63, and then that should be enough to get me all the way down to the bottom one. Perfect. Okay, so now just encoding the ROM becomes a little bit of a challenge, but what we do is these bits are the instruction set bits. Yeah, this is a ROM. So for instance, here I'll put in some, alright, so we'll put in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So now, if we're just looking at, I'll just put a lamp or something. Alright, so this would encode 0, well, and then 1, 2, 3, but you can go pretty quick with it, it's not going to fuck up. Why am I banned? Man, that's a long story. They claim it's because I was. So what was it? I was writing a constitution for a new server, and I was using the previous OR constitution that was written by me and a bunch of other fellow OR members or admins as a base, and I shared that with them. And they got mad that these publicly known addresses of these people were now shared with another group of people, and as if that was a bannable offense. They used that as an excuse, in my opinion, to ban me because they didn't like that I was working on creating a competing server. Which ended up falling through, but who cares? Like, that's not the point. The point is, they used whatever bullshit reason to try to ban me from that. And the day before, I thought I got banned because we were building a minecart adder on the server. Which I have like 4 hours of footage recorded that I kept. But it's like, I'm kind of grateful for it because, A, I don't even know if I'm unbanned. I've never been back, so I actually haven't ever even checked if I've been unbanned yet. And that was 2.5 years ago. And then the other thing is, like, I met Nano and a lot of other people and started playing on Top Red, and like I wouldn't have been doing this stuff if I was still on OR. Yeah, I think I got pretty good at Redstone just by learning how other people do things and not staying stuck in the OR bubble, because OR is kind of just stuck on doing ALUs and making them better continuously, which I guess there's nothing wrong with, but build something with them. Wait, let me do this the other way. I want to like go pretty quick here and see how fast it can actually go. Oh, it fucked up. Oh no, it didn't. It just can't reach. Oh fuck. Okay, that's an issue. Oh shit. What the fuck am I supposed to? What the fuck? Alright, anybody have any advice on how to... boy. Is the CPU already jumping? I'm working on just getting fast enough stages for the decode, and then... Okay, so it's going to be a 6-stage pipeline. I'll pull it up from my Discord, what my plan is here. Discussion. Okay. This is what I got currently for the pipeline stages. I'll type it in chat. So the idea here is instead of like yeah. Okay. Before I get to the comments on how to fix this, but so the idea for the CPUs, I'm gonna have, instead of like it's like the way a normal 5-stage instruction pipeline works is you have instruction fetch, instruction decode, execute, memory, write back, right? In this, I'm splitting it from address decode and instruction fetch to instruction decode. So like I'm adding an in-between phase between like in the instruction fetching. Nice. Like I'm really doing this for the pure purposes of having a good programming model, because like so if I go to like this guy is just too big to really deal with. What was nice about this in Telered was I had 32 16-bit registers, so I could implement the whole MIPS instruction set, and that's basically what this is. The issue is it's so fucking big that even with 6-stage pipeline, it's 22 tick clock. So that's why I'm working on the other one. I'm building this for, oh, okay, so we have a graphics pipeline that we're going to be trying to control, and it would be nice to be able to just make it general enough that we could just issue commands through a controller to it, instead of having to build like an ASIC controller for it. I'll type it in chat here. If you play on Bedrock and you want to join, just type in bedrock.topred.fr. So yeah, I'm hoping to have like, well, when I lay out the instruction set, which will be coming up in a few minutes, you'll see that I'm gonna hopefully try to get. I typed it in chat. Next. Also, Quack, yeah, that's really cool that you guys are also working on fast processors. So far, I know that Stack Overflow, or whatever it goes by nowadays, I think he built like an 8-tick one, which is, or whatever 1 over 0.8 is in terms of frequency. But what I'm gonna regret having to do here is put like a. Actually, wait, maybe I can get away with this. And that can be the pipeline register. If I do something like this. The only thing that sucks about this as a pipe, oh my god, yeah, that's also another thing that sucks for, well, I guess I can use the wall trick still to do the downward buster. I was gonna say to trigger all these registers to actually latch, right? Hey, you guys joined. Yeah, you can do TPA to me, and I'll accept it. It's a different server. It's not. Well, it's the same server. It's 2 different servers on the same server, like cross world, but you can't world edit between them, but you can TP between them. So you just do /TPA, and then I'll let you come through. But yeah, so now I should figure out how I'm gonna do that, which I think I'm just gonna. Okay, so I want to copy this from the output, which would be a redstone block city. Yeah, so copy from here. Then I have to rotate 90. And now to make sure that it doesn't fuck anything up, I'm just going to move it like over here. And paste. Okay, that seems like it will work if I undo that and just stack it there. And now the default state would be them being, oh, I'm too far away. Okay, undo, paste my state, there we go. And the default state would be that, and then when you send an update, pull them back and boom. Cool. Okay, so there's a, okay, that's so fucking easy. I'll take it. I'll take it. Okay, man, that's real nice. Why does it sound like somebody just brought a chicken inside? Alright, sorry about that. Alright, so I gotta stack these walls down like this. And then I can stack this down. Hey, Fitzy. I hope I'm pronouncing that right. Oh, I'll accept that. Ah, fuck. Let me undo that and then rewrite the register with a 0. And then I'll restack it. There we go. Damn, that's not bad. So I could oof. Somehow fucked up that. Oh, I know why, because I okay. And then I'll do this so I can see it get written. So I can write this guy, change the input signal strength, and then rewrite it. Boom. Cool. Well, that's pretty cool. Op is asking what I've built. Do you want to see what we're working on? Let me see. I forget the name of the home. Slash ehome GPU 3D. Ah, fuck, wrong one. Sorry, but I really think I'm probably more advanced than what they're building on other servers. Like, it took a really long time to find people that understood how to do this. Where is the, what is the name? What is, oh, 3D VSP. Yeah, like, for instance, I think this is, like, me, Pensy, and Nano designed the most compact 5Hz 16-bit signed multiplier. Like, that's this right here. There's gonna be a lot of background noise. But anyway, yeah, that's a new number every 2 ticks, aka 5 Hz. Yeah, right, when all the names are already taken. Yeah, so that's the multiplier that we were using for then our 3D vector stream processor that we're working on. It's 3D, but it has a 4th dimension called W that allows us to do perspective and projection. So that we just divide the X, Y, and Z coordinates by W, and we get the scaled coordinates to project onto a screen. And depending on how big W is, we can change like the field of view on the camera or whatever. So yeah, that's kind of what we've been working on there. Graphics, but now to get back to the CPU. Oh, I mean, I can show it, like, yeah, okay, for shits and giggles, I can run this on stream because I'm sure you guys want to see it. Well, welcome, JJ. So anyway, so when I click this button here, it's going to start 12 lines at once. So each screen is pipelined for 5 Hz, but each line drawer is only 6 ticks. So if you dephase 3 of them together, you can draw 3 lines at once per XY decoder of the screen. And so with 4 layers of the screen, we're able to draw 12 lines at once. Although this does kill TPS. If you look on my top in the right, underneath my, or above my name, it says like 5.19 TPS. So if this was drawing at 20 TPS, it would take about 40 seconds to finish the frame. So we're hoping to eventually be able to do a frame every 40 seconds, which is about 1.5 frames per minute. So that would be pretty cool to have be able to render 1.5 frames per minute, and then like actually be able to see a 3D rotating cube. Gotcha, Fitzy. Or Fi-C. Fi-TC? Yeah, but then you'll see that as it finishes up, the ticks per second starts going up as there's less lines being ran in parallel. So Pensie's the person who actually designed these line drawers, and Nano had the idea of dephasing them and whatnot, and I just kind of helped get it all together. But so now we're working on like dispatching units from, okay, so like the idea is you send in a list of vertices into like a matrix transform, and then it spits out the new vertices, which then you have to reconnect with lines. So you need all the dispatching logic that will do that. Running it with AC, what does AC mean in the sense space? We've tried the MCH PRS server. We're trying to make this work like on that server because not every block was implemented on the MCH PRS server. So if you want to actually like use observers and whatnot, Nano actually recoded it to support observers on that server. And MCH PRS is developed by some people on OR that it's like a high-speed Minecraft redstone server. Hey, welcome to Lugia. Alright, there might be some background noise in the stream, but sorry, can't really do much about it right now. Alright, so now what I need is to figure out, so it's like 1, 2, 3 ticks synced for all these addresses out of here. I believe then this piston is 4 ticks, and this stage here makes 5 ticks. So I'm actually able to not need to split the stages so far. If I do need to split the stages and put a register in between the decode and whatnot, I can borrow this design from here, I believe. It's 1 wide. Alright, I'm just gonna like lower my mic here for a second. Give me 1 second. Okay, I'm back, and people put me in a box. /THRQ. Okay, alternate current, the more efficient redstone dust mod. Oh, I've never even heard of that mod. Okay, so... Oh, really? Okay, so now, yeah, maybe he might have been testing it, but I don't usually join all his test servers because they're fucking whack. Yeah, I'm not sure. He tests a lot of different things out. I'm trying to think now. Okay, so I don't know if I'm actually going to need all these bits in the ROM. But what I do know is I'm probably going to have to move this back and fit this vertical register in there. So let me try this. Oh, excuse me. I believe that's the entire register. I don't know how I'm gonna actually use it, but I'm just gonna copy from there. Alright. Paste up here. Okay, so that's gonna have to be the output of this red coder. We'll have to update this observer, I believe. So that would just be like pushing a block in front of it, I hope. God, I'm so bad with piston stuff. Let's try that. Oh, that's right, and it's a register, so then I need the right mechanism, which is this up here. I hope I'm pasting this in the right spot. Cool. Okay, so data. Oh, wait. Reset. This needs to act like a clock, not just like a reset, but whatever, I'll figure that out. So is moving block the only thing that can update the observer, or like turning dust on and off also does that, right? You fire right and reset in the same clock tick with the correct update. Okay. Okay, that's how you're doing it over there. But dust can. Oh, okay. But then if I wanted to update the observer with, I could do this then. If I wanted to use dust. Oh, I have that facing the wrong way, don't I? Fuck. I love how Luigi is invisible. Oof. Something like that. Would that work? Stream delay pane. Yeah. I don't have it set to ultra low latency, just low latency, so whatever that means. Yeah, I think that's fine. Okay. And then I can just reset with that. And then that way. Then, wait, will torches do torches here? Like this? Awesome. Cool. If torches up. Yes, okay, cool. Okay, yeah, so this is what I'm gonna use then, I think. Oh fuck, that's right. Placing these is a bitch. And this can be 15 long if I use dust then, right? Position 1. I guess I'll do position 2. Stack 15 for a total of 16. And then the right signal would have to be like here. Ah. Oh wait. Oh yeah, but I can't make my red coder use that trick. Also, that would be weird to address since it's not a power of 2. Okay, so now I need to get the red coder output to here, and then that will go into the ROM. So let's copy it. And I'll just copy from the 0 location. Oops. Should have probably just copied the whole thing, whatever. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, I got that right. Holy shit. Let's see, does this work? Oh yeah, but you need to, that's right, and then you clock that. But this updating has to update when this does to make it act like a write. Hey, what up, Nugget? Oh, Space, Nano said he was messing around with your multimeter mod, though. He was trying to get that to work. I can use tile to priority to update this at the right order. Yeah, so now I just need to build like a hex counter or something. Well, more like, okay, so there's two ways I could do this. I can have a binary program counter that converts to hex, or I could just do it all in hex. I'm thinking maybe just doing it in binary, so I can just use do it in binary and then have a hex converter. But then I would need a synchronous hex converter. Okay, there's got to be. How would I do a synchronous hex converter? Oh no, I know where one is. Actually, I have one. Just got to find the plot. Where is it? Is it by? God, I don't know where it is. Hey, what up, MP? I'm trying to find the warp to where I might have. Oh, it's Snake slash. Yo. Fuck. It happened like 2 years ago. I started a competing server. They used a bullshit excuse of people's public emails being shared, which were public, so there was no issue. But they used that as an excuse to ban me because I was creating a competing server with data corruption. That's the short version. And where is my hex? There it is. Okay, so I believe this right here, half of it is world edited away. What the fuck? Yeah. But I don't know if I'm unbanned. I haven't been back to try to see. Open Redstone Engineers. I was admin there for like 5 years. Where is... Oh man, this is upsetting. Okay, so this was sync 1, 2, 3. Oh god, that's so many ticks of delay for oh my god. This is so hard to fit in 5 ticks. Yeah. Nano has a plugin that creates plot floors, or just floors with whatever functions you want. But you need to have like full render distance turned up, 32, because the server has 32 render distance, so you might as well take full advantage of it on your client. Yeah, I'm upset that half this is missing. Alright, so then I'm gonna need like a hex incrementer. If I do it all in hex, slash, I'll go back to where we were, eHome graphics, I'm gonna fly back. Oh no, did it crash? No, it didn't, okay. I'm surprised it didn't. Okay, so what I'm trying to do is, oh, I didn't realize Luigi was working on this. Dope. So, wait, is this like getting QC'd or something from that? Or what's going on there? There's a few seconds of delay in chat though. Rip. Does this work? No, I don't. Can something like this work? Man, I don't know these mechanics of like observers and fucking pistons and stuff. I mean, I do everything solid state usually, so this is literally breaks every design principle I have. Oh, Joe. Smart. Okay. So if I put in 15 and this should be true. Wait, what the fuck? Oh boy. Okay, so Luigi is going at it here. Let's see what he's got. I don't know if that was supposed to break, but night vision. Take some night vision, bitch. So this is just a toggle. Is that to prevent QC, or you have to run rail up there or something? So this one should just be on right now, so it should be like that. Like so this should write. Well, this is still gonna have to be an independent clock line. This won't be coming off of that changing. Kind of similar to how we set it up over here. I gotta wait for the few minutes of chat delay to get to him. A few seconds. It'll be like what we did the other night here, Lucia, where I have like a counter counting with a clock. But I just need to build like a hex counter now, which is probably just easy as Google search just to see a base, and maybe I can improve it from there. Oh man, I'm probably gonna just have to do it all myself. Oh, there we go. Okay. I got one from Not Mad Matt, and that looks like it'd be pretty good. Where does the clock signal come from, though? Black is +1. Gray, memory cell is the output. Shout. Light gray is -1, okay. Wait, what? That doesn't make any sense. Oh, if the light gray input is true, then okay. Okay, I see. God, this video is really low quality. Alright, let's see a countdown. I don't know if I need like it to decrement as well. I feel like that's just extra added logic on there that I don't need. Oh, sorry, our fee. If you resend the request, I'll accept it. This is a clock line, so I can adjust the delay on a clock line and sync them. It doesn't matter, as long as all the clocks have the same delay from the main clock. What I do need to build now is a hex counter to stick on the input of this instead of... Thanks, MP. Hope to see you around. So we're going to do this and this. I need to comparator. Okay, and then comparator here. And then I need more floor space. And that's going to power into that guy like that. Peter will prevent that. Power in. I'm just going to build it exactly like he has and then take off the shit I don't need from it. I'm just following like a little post on Reddit right now. Post atmosphere. And there's a comparator like this. And then that's like an observer. Observer. Assuming it's like this. 1, 2, 3. Comparator coming into the comparator, and that one's also on subtract mode, and then getting power from the side through that latch like that. The cake behind it's probably for like what, 14 signal strength. Is that? Oh, okay. 14 signal strength. I believe a full cake is 14 signal strength, right? And then, the fuck is that? Is that a lamp? Oh, it is a lamp. Okay, so he's using a lamp to update that. So he's using a lamp through this, and then an observer face like that. I don't know if I did that right. No. There we go. So I want the face on the input. So, okay. And then it looks like he has a lamp here or something. I can't tell if it's actually a lamp or not. Let me see his video that he made on this again. Oh, it's not a lamp. What the hell is that? Just dark black or something? Black. Oh. Oh, okay. I see. They're not lamps. I'm stupid. Okay. Now the output of the cell here comes back through a comparator into a feedback loop like this. Now there's also another comparator going this way, which is on not subtract, just on regular mode like that. Oh, and this one can be on regular as well, it doesn't matter. And then here is the output, hopefully. Well, let's just do it short. Alright, now let's see what the fuck I did wrong. Oh, maybe because I need the rest of the logic in there too for it to work, I don't know. It would make sense. Alright, so that goes through 2-tick repeater into a block, do a comparator. On subtract mode, yeah, this is what I need to clear this. I know that just brings it back the other way. Whatever. We'll see. And then this gets redstone like this into another 2-tick repeater. Oops. Okay, I'm glad I got that cake right. That's one thing I know. I don't need this logic, I don't think, here for this part, but whatever, I'll put it on here. Okay, God, that looks fucking confusing as fuck. And it's not doing anything. Woohoo! What the fuck? Alright, let's see. Oh, because that's not... Okay, well, that would be one reason. That is not supposed to be... I think it just needs a good amount of signal strength coming out of that. So maybe it's... What signal strength is in that container? I do not know. It's got, yeah, it's got to be at least 15 now. I'm gonna put 15 in. If it doesn't work with 15, I got 14 others to try. Oh, okay, let's try this. This is why it wasn't working. Okay. So 1, there we go. 2. Oh shit. 1. Why is it clearing itself? He used, I think he was using some sort of door, so maybe trapdoors will work for this. It does 1. It goes to 2 and then resets. Alright, well, I'm missing a timing on something. It's gotta be what's going on. It is 14, so put a boat in there. It's just going 0, 1, 2, 0, 1, 2. Let me think. Alright, let's do this so it's got a 1 in it. Oh, maybe this is the wrong signal strength in this. Oh, yeah, it's supposed to be... Yeah, that's what's happening. I think this needs to be a 1 signal strength, not a 15. Instant is definitely not better, buddy. Well, it depends on the application, I guess, but for a lot of computational stuff, it's never better. So I'm gonna assume that needs 1, 2, no, 1, 1. Okay, well, at least it's not resetting itself. Maybe... Does his post say? Alright, well, I guess I start trying other signal strengths. Try 14. Is here no block? Yeah. How do I get it into an oscillation now? Oh, because there is no there. This needs. Nothing. Nothing. So it's got to be 15 then. One, two. Why on that is it? Arfie, yeah, this is right. That's how it's supposed to be. That's why you're flying around it. I'm curious how his is working, mine isn't. I'm definitely thinking it's something to do with the signal strength. Or maybe that cake isn't supposed to be 14. Maybe it's partially eaten. Let me see this video. Oh, that's a full cake. And then it's powering in full. Yeah, so this is 14. Coming into here, which is full. Powering into the block here and there. Why? One. Then I think it's too much delay on this. Like, what happens if I... If I remove a tick delay... One... No, still does it. Now I was removing a ticket delay. Here's putting that ticket delay back. Hey, welcome, Flucus. No. He's wrong, but we'll do it anyway. And then he'll get the fuck out of my way. And does it work? One. Nope. Alright. So now do you see you're wrong, and I'd really appreciate it if you didn't tell me what to do now. Thank you. Well, I'm literally looking at the model. There's got to be a timing issue. When it's at 0, Now it goes to 1. This going to 2 should be synchronous, and this should never flash. But instead what's happening is the cell's getting cleared, turning that off. This isn't resetting anything. This is happening after the cell clears. I'm going to try changing this to 2 ticks. Or maybe just 1. Too fast. 4. Oh! And now is it going to clear? It went 1 further that time. Okay. Something... I really don't get why... Alright, I'll send it in... Alright, let's try the decrement side. 14, 13. Okay, the decrement side is working. 7, 6, 5, 4, 3, 2, 1, 0. Maybe I just use the decrementer and invert the output. Honestly, I might just use the decrementer and invert the output, because that would be a lot easier. So if I, well, before I should probably just make a copy. If I could spell. There we go. Alright, so if we ignore all this bullshit, now we have a decrementer. Ah, fuck, what did I screw? Oh, did I delete this? See, this is why I made it. Okay, wait, watch this. Alright, does this still work as a decrementer? Yes. Okay. I broke the wrong thing. There we go. Okay. Okay. Now if I just, what's the easiest way, least messy way to do this? Oh, comparators pull from their side. Fuck. From a redstone block. Alright, well, whatever. Distance to delay through that doesn't matter. I can do this. Alright, so there's my janked up incrementer. Oh no. I'm a dumbass. They can't pull power from their side from the torch. There we go. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 12, 13, 14, 15. Yeah, so there's a hack together incrementer. Yeah, just do that. Well, oh yeah, because it won't power from a container from the side, but it'll, yeah, okay. Although those are 14s, not 15s, shit. Good idea. Man. There we go. Yeah, the only issue now is if I want to branch, right, and I want to write a value into the cell, I have to invert the value I'm actually writing. So if I want to write a 5, I have to do 15 minus 5 and write it to 10. so that when it counts down from there, it's right. But that should be as easy as flashing this here, and then overriding with the new signal strength you want here. But I need to invert it, so we'll do this. And then the right signal would also have to come into this here as well, which can be pretty easy. I guess we can just do it like this. And then tie these together. We get a button. Alright, so that should have wrote, oh, well, the issue is that it should take the 15, not the 14. Yes, okay. And, oh, shit, this ink that has to be, this is gonna have to be inverted by default like that. So now it won't allow the signal through. Okay. So now if I write, cool, it's writing I wrote a 0, which is 15 there. Now I can decrement 15, or increment 1, 2, 3. Okay, but now if I want to write a value in here, let's just pull this way out. Say I wanted to jump. Let's say I wanted to jump to 7 on the output. Hopefully this does that. Yes, okay. The only issue is it flashed 15 before it did 7. So the CPU itself can't be hex because you can't do logic computations in hex. There's no hex one. Like, it's all bitwise and bitwise or bitwise XOR, that kind of stuff. Ugh. Just switching. Ugh. Yeah, so since they're all bitwise, you can't do any logic operations in hex. You'd have to convert everything to binary to do that. I mean, you could do addition and subtraction, multiplication, and division in hex, but you can't do Boolean logic. So this is just going to be like my idea for like a program counter, maybe. And now I should go to 8. Oh, well, 9, because I updated this twice. And 10. 11. Yeah, so, and the only reason he's doing an observer there is just because he wants a short pulse. So if I use a piston, I can do the same thing here. But now I don't have to deal with it triggering twice. So I can use a normal clock. And then I can say branch to 0. Actually possible with mod bitwise and one. No, it's literally impossible. It's bitwise logic. You cannot do it in hex. Like, if it's possible, there would be proofs written in mathematical papers, but there's not. I've had this argument before so many times, and I've even made a video of it on YouTube, like on my channel. The video is called like hex logic gates, question mark, question mark, question mark, and the idea is like you can't do it without converting to binary and converting back to hex. Like do like 3 and 5, right? What do you mean? You think Minecraft Redstone isn't math? Dude, it's literally all math. Like, what are you talking about? Like, the redstone is 100% analogous to like how you do math with logic in real life, except for the fact that like hexadecimal signal strength doesn't work like that in real life. But the binary stuff is all 100% the same. But the literal math guides the logic for the code, so like it's all math, dude. Come on. Like, the only way you're able to increment and decrement is, do you understand, like, if they're doing subtraction by default, that's more powerful than addition, because you can do a minus negative b and get addition. Like, that's how the adders works, right? Like if you have a plus b, but you can only do subtraction, so you do 0 minus b and gets you negative b, then you do a minus negative b to get a plus b. Alright, like, that's strictly math. Okay, now using that math and using notation, how do you get 3 NAND 5, for example, using hex logic? You can't. You can't do that because 3 is 0, 0, 1, 1, 5 is 0, 1, 0, 1, and the NAND result, it would be 1, 1, 1, 0, right? So your result would need to take 3 NAND 5 in hex and produce E as a result. What do you mean it doesn't have negative numbers? Do you know how 2's complement works? Yes, it has negative numbers. Do you know how a complement works? You take it, for example, in hex, you take the 15's complement, or, well, it's really 16's complement. In binary, you take 2's complement. In decimal, you take 10's complement. If I want to do 5 plus negative 3 in decimal, and I have a 2-bit system, or a 2-decimal system, so I have 05 and 03, right? If I have 05 and 03 in a bit system, and I want to make 3 negative, it actually becomes 10 minus 3, which is 7. Then I do 5 plus 7, gets me 13, and I throw away the first bit, which is 5 minus 3, or, well, it's 12, sorry, not 13. I'm an idiot. It's 12. You throw away the most significant bit because that was your carryout digit, and you get 2, right? So that we just did subtraction in base 10 using 10's complement. Okay, are you going to tell me that's not a negative number? That's how you represent negative numbers. So the same way you represent negative numbers in decimal, same way you represent them in binary, same way you represent them in hex. So by that law, you can do addition, subtraction, multiplication, division. Like, you can do arithmetic operations. With hex, yeah, I'm not arguing you can do arithmetic operations. What you cannot do is logic operations in hex, because they're bitwise logic operations, not hex-wise logic operations. So I just showed you the math that proves that you can do addition with hex, or you can do addition in any base. Okay. And using that, I could then continue to prove multiplication, because the multiplication is repeated addition. I could then prove subtraction, because we already proved subtraction to get the addition. And then I can prove division, because division is repeated subtraction. Okay. Now taking that, can you prove to me using hex, mathematically, that you can generate any logic function? And I'll tell you right off the bat, it's logically impossible. That's why there's no hex CPUs in Minecraft. They control logic, program counters, that kind of stuff can be done in hex. But you'll only have an arithmetic unit. You won't have an arithmetic logic unit, which is needed if you want to do like bit masking and yeah, feel free to actually prove it, like mathematically, using like Boolean notation, using, you know, not signs, ors, and ands, and then whatever hex notation. Like, you in hex, the only operator, which is unary, is the not operation, which is the inversion, which is the complement. That's the only logic operation you can do. There's no functionally complete NOR or NAND. And if you look up Boolean logic, to do any logic operation, you need to be functionally complete. I still don't know why the fucking increment 1 thing on this doesn't work. Hey, welcome. How's it going, Timberman? We were talking about your doors the other day, and I believe it was your doors, in another Redstone server. Why? So the subtraction side works. No? No, the subtraction side on that one doesn't work anymore? God, this is so bulky. I wonder how fast I can clock this. If this would even support the speed I want. One, 2, 3, 4, 5. Oh God. Yeah, so that's a 5-tick clock, right? So that's 2 hertz. That actually... Oh, yes, it's working. 7, 8, 9, 10, 11. Okay, sweet. I was a little concerned there, but that's actually working. Cool. Okay, so I can stop this. And I will move this out of the way. And I'll paste a clock incrementer onto that. Alright, let's see how fucky things start to get. I believe he did some bullshit like this. I really don't know. Alright, now wherever Lucy is, if you could come out of being AFK and help me. Night vision. So occasionally it was up to, oh my god. What the heck's going on? One, two, three. Yeah, so like, but this is must be a few ticks off or something. No. Yeah, now there's some timing stuff that needs to be done on this to get it to actually work. Because if I don't send this pulse through, you just see that it pushes everyone over. Oof, what was that? That was interesting. Ew, that's an issue. What the heck is that? 1, 2, 3, 4. Both of those don't trigger it. Something is causing two of these pistons at once to trigger at the same time. What's causing those two? Oh, welcome back, Elygia. It's so weird that it's only in this spot. I just removed this to prevent that from updating this yet. What do you do to the clock here? Oh. Oh, nice. Start, stop. Gotcha. Yeah, there's about to be some noise in the background. The couch is being moved into the living room.
Alex, keep the pencil in your jokes in case you judge them.
Oh. 1, 2, 3, 4, 5. Well, yeah, still 5 tick clock, so whatever. I guess if that was wrong. Interesting. Okay, so now if I want to hook this up so that it writes, we want this hooked up off the clock here. So it's only going to write when the clock signal comes through. Let's count it right now. It's 1, 2, 3, 4, like 5 ticks of delay. Redstone ticks. Yeah, we might literally just be clocking it as fast as it can go. Oh wait, no, 5 ticks to the output here, but the loop itself is the loop itself is 2 ticks, I think. And then the control logic is 2 ticks to get to it. Oh god, what are you doing there? That's looking... Yes. 3, 4... Wait, yeah, did it mess up the beginning? Yeah, that was really weird at the beginning. The comparator has a different delay than... Huh. Gonna just lower my mic as shit gets moved in. Ooh, that was really quick and then moved to the next one. Oh, you're trying all sorts of different mechanisms to update that. understand how. Like I only know them in terms of red zone 6, so. One, two, three, four, five, 6, 7, 8, 9, 10. Each one of those is a game tick delay then? Oh, nice. Yeah, that's very weird. How this. I wonder if the comparator on subtract mode changes it. No. I'm trying to think, do I even need... Yeah, I do need a register because if I branch, I need to hold the address that's... It might not be consecutive between what's the decoder should be looking at versus what the output of the decoder had from the instruction before it. So yeah, it does need to have a register. Oh, fuck. I need to grab another barrel. I just need to check when it's not 0. Did that? Oops. No, it didn't even trigger. What the fuck? Why did that not trigger when that went to 0? Oh, it's not updating the right side of the observer. Yeah, maybe... I'm not sure either. Alright, sorry, I'm back. Yeah, with ROM you could encode every logic operation. Yeah, I'm not going to disagree there, but that's not doing the logic. That's still encoding it in a different form, which is basically as stupid, or basically stupid because you might as well just convert back to binary if you're going to encode it into a ROM to do that, which is going to take all that time anyway. Yeah, why is it when it changes the first? Yeah, okay, let me think about a pipeline diagram here. Because I wonder if I really need that register. Or like a waterfall pipe it. And just treat it like one. No, I don't know. Just threw away that, but I wanted it. Okay, so let's do it like this. We're gonna have some ROM. ROM. This will be the address decoder for ROM. And then out of the ROM comes the instruction. Alright, repeaters will designate as latches. So of course the instruction gets latched out of the ROM, and I think this is how I'm pipelining it. Is the counter slow when depowering? Oh, maybe. If you put a repeater... Oh, okay, that's one way to test. I was going to do this. I don't know if this will see those ticks that you want to see. I don't know if that'll help see the speed. According to the repeaters, it depowered synced. So there should be 5 ticks in between each one, and then they all turn off at the same time. Every pipeline CPU has hazards, but I think what you mean is will it have hazard detection, and yeah, they will have hazard detection and forwarding logic. I'd love to see that 2 Hz CPU if they actually have one. You could send a link in chat or something. I'd like to see how the instruction set is laid out. Yeah, I'm gonna have to use a lot of piston muxes. This should be power for 6 repeaters, but it's only doing for 3.
This is for the chair. Oh,
Maybe the desyncness is something to do with.
Bring it in here. Let's have like a little funky bread.
Anyway, that's okay.
I think it's that loop right there that's the issue.
What pieces?
Yeah. Back.
Oh yeah. I just want to put it aside. You want a glass of water or something to drink?
I don't get if these both hold the same signal strength. I'm not quite sure what's going on here. 4, 3, 2, 1. Well, if these both have the same signal strength, which obviously they do if they're coming off of that. Yeah, Luigi, I'm starting to think it's the counter too, because I'm trying to. It needs to be synced in both the going up and then resetting to 0. And if it's not, that's what's fucking it, you know. What's the docs? Fire Tinder. Anyway, does the CPU support like any general purpose register being a pointer, either for RAM or ROM, or data or instruction? Because if it doesn't have support for that, then yikes. So I gotta figure out what's wrong with the counter here. Wait, why is this on 2 ticks? What if that's on 1 tick? What the hell? Okay. Three ticks. 3 ticks doesn't really. Yikes. Was that on 3 ticks originally? No, it's on 2 ticks, okay. Alright, Elusia, you know a different counter? Because I don't like the way this one works anyway. Yeah, this is the boatman.
You gotta flip it up a bit, the parts underneath it, and then you get it. No. You don't have to flip up exactly because it came from the bag, came off electronics. Get off and we'll set it up.
Yeah, I'm gonna need to get a different counter. I still think maybe like the.
No, they had 3 things. Drop it off at the curb, bring it in, unpack it, and leave the boxes.
Alright.
Oh, so they left the box.
Yeah, I got the box right there. I take the boxes right in the wood store.
Alright, I thought I had a copy of this counter before I fucked with it. I basically need to get the incrementer version of this working instead. Because I think it's something to do, because I'm using the decrement one with, and then inverting the output back to being incrementing.
Take one, it's on wheels, so you're not gonna get crazy with you.
Yeah, I'm gonna need to figure out another counter. Can't find one that's not trash.
Is somebody already gave me my glasses. See, I'm holding this and coming back.
Yeah, I'm gonna stop this clock here. And well, okay. Well, I can worry about a counter later. I still want to get this pipeline diagram laid out. So this latch and these latches. This is one redstone tick, which means I have 4 redstone ticks to do the rest of the logic. Like here, I would have to maintain 5 ticks because the latch is a tick. So that would give me, from the time that the address was decoded, it would give me 4 redstone ticks to get it to appear at this repeater, and then this is the 5th tick. Same goes with this. So if I have a ROM decoder, I have 5 ticks to get that from program counter. So from the output of the program counter, I guess I can do this. Yeah. Okay, so the output of the program counter is obviously a register, which means I have that 5 ticks delay to get that from the output of that register into the ROM decoder, then 5 ticks of delay, well, 4 ticks, and then this is the 5th, then 4 ticks from the lookup of the ROM into the instruction, and then from there it'll hit the CPU. So normally this register isn't here in a 5-stage pipeline. But then from there, I'm still going to need to figure out, like I'm going to have to build a data loop that's able to support the amount of register. Like I'm hoping I can fit 7 general. So yeah, maybe yeah. So if I do instruction decode, do it in orange.
How am I supposed to accept? It's tell you if I want to get on 5 yes.
Okay, so the instruction gets fetched here, is seen here, some gets decoded, and then we have bus wires coming out of here. That this would be like the address for the registers and whatnot. So then the register bank, I'll just draw. We'll do it with what color? I guess purple. So obviously this is not to scale. There's really 3 inputs into the register bank and 2 outputs. The 2 inputs are like read A, read B, and then the write destination. Okay, so now that so the idea would be this would take like, I don't know, the 4 instruction bits in and decode out all the control logic, and the rest of the lines would just be like the immediate bits and whatnot. So the register itself has to be 5 ticks, and then the decode logic can't be any more than 5 ticks. So the next pipeline stage would sit here. So I'll just write this as instruction coder register file. Okay, and then obviously the 2 sources here. Oh, and then also we need a pipeline through the immediate bits. Call this the immediate, we'll pipeline that through. Okay, so now we have the ALU over here. I don't know, we'll make that blue or something.
Are they the same size?
Well, it that basically rules.
Okay, so it's either going to be that, or we'll mux it with the immediate. So RAM address generation is the result of this. Or you can do base register plus offset gives you the RAM location. That's how pointers work. So this will then be the RAM address stage, so the memory stage. Then if we're just bypassing data to, okay, so nope, the muxed one here that's not taken would then be this. Okay, so then this is like data to be written to RAM, and this is address generation. Else, this is then write back for register data. And it skips the pipeline because it's forward data coming back. And then this is, oh, I guess I'll do it like this. Data into the register like that. Data in, put a little arrow. Okay, so the idea here is you can, if you're doing arithmetic op, obviously you load two values into the ALU, and it's either, for instance, it's either an immediate and a register value or a register value. You do the operation and you can write back to your registers. Or you're doing like a load word, store word, and then what ends up coming in here is the base pointer, and then the offset amount from the immediate, and then the data to be written is the other source. It comes back. Okay, so that covers both load word, store word, and then arithmetic operations. Now we just need the RAM, which this is the RAM. Okay, so this is going to be address. This is going to be data. Obviously a clock line comes in here, but I'm not going to draw the clock lines everywhere. Holy shit, can my family be any louder? And then this is appearing on the write back bus as data out of the RAM. I'll just draw an arrow instead of putting a repeater, because repeaters designate pipeline stages in this diagram. Okay, so now you can calculate stuff to load from a register value and store that into RAM, or you could say load RAM and then bring the result back into a register location. So that's going to be the diagram. So you can see there's 1, 2, 3, 4, 5 pipeline stages, which means there's 1, 2, 3, 4, 5, 6 pipeline stages actually, because it's like the registers sit in between stages, so there's one on each end. In a normal 5-stage pipeline, there's only going to be 4 register sets, not 5. Now the issue becomes all this logic in between every pipeline stage can only be at most 4 ticks, because the pipeline stage itself is that 5th tick, because of, you know, D flip-flops in Minecraft having, like, or repeater locks being 1 tick of delay. So that makes this kind of hard. So I may end up changing it to 6 or 7 ticks, whatever I can actually fit. Yeah, Fire, if you want, I can show you what in my opinion a good instruction set looks like, because it's github.com/ where the fuck is it? GitHub Why can't I find this? Oh, because it's saved in Firefox and not Chrome. Oh, we're gonna have. Why is it trying to save? There we go. So this is my IntelliRed instruction set. But if you want, I can go to drive. Hold on 1 second.
You better not be bleeding on
Yeah.
They have you read Bob.
ISA. And then I can show you the Google Drive link if you want to see some more examples. Share. Anyone with the link can view. So there's a lot of instruction sets in this document, ranging from sheet 1 to sheet 4, and sheet 4 is IntelliRed, and sheet 1 is what I started with and worked my way into IntelliRed. So you can see like this is some of these previous ones are pretty fucking sad. Like, sorry excuses for instruction sets. Like, I have a compare operation. Like, okay, so this was back before I realized that you don't need to save flags registers. Like, there's no need for flags registers. Like, in fact, both MIPS 32 and RISC-V don't use flags registers. Okay, knowing that is great and all, but then how do they handle signed and unsigned shit, right? Okay. Well, the way IntelliRed works is it's literally a copy of MIPS 32, but just MIPS 16 instead. So I have some instructions called SLT and SLTU, which is signed comparison and unsigned comparison, basically. So set less than, which is signed, would say if RS1 is less than RS2, so you can have like -5 is less than 3, right? Then that would be true. And if that's true, then it's going to put a 1 in RD. So if you have 32 registers, you can decide what register is going to be, or 31 I should say, you can decide what register is going to be your flags register by just writing back the result of this into that register. Then to check for the result, it's just as easy as checking if equal to 0 or not equal to 0. So branch of equal, branch not equal, and then you just put in zeros for that. Or the other branches that are powerful is branch less than or equal to 0, branch greater than or equal to 0. So using just some very simple branches and the signed and unsigned comparison, you get to do everything that a normal CPU would have like flags registers for without having to worry about storing flags registers when you enter a subroutine, right? Like if I'm in main in my C++ program and then I call another function, I need to save the state of main before I enter that function, which means I need to preserve this, like the state of the flags registers. But if you have no flags registers to preserve and your register that you're pushing into the stack just happens to be all of your general purpose registers, and one of those general purpose registers held your flags data, then you don't have to worry about storing some like other register that you have to worry about where it is and how you're going to address that. So IntelliRed is very powerful in that regards. Like, and then it's also super easy to instruction decode. Like this is the decode table. So it says 32-bit instruction. That's actually wrong. It's like 35 bits because I added like a bit in here and then never updated what that was, or added 3 bits in. I should have, since I was making it, once I made it an odd instruction number, I should have just also added an extra bit here so I have full 16-bit immediates instead of 15-bit ones that I have to sign extend and then use like the most significant bit of the immediate to tell it what type of format I'm in for the instruction. Like for instance, add has 2 formats. You can add as 2 registers together, or add to add like a register and an immediate together. But since I'm using the top bit of that 16-bit immediate to tell it like what format I'm doing, like it can only be a 15-bit immediate, and then to get like a full range, I'm doing a signed 15-bit immediate. So if the most significant bit is true on that 15-bit, then its sign extends to the 16th bit in data. Then what's theoretically possible in this, for instance, is like base RAM address 0000, max RAM address is 0FFF, base MMIO would be, you know, then 1000, and then max MMIO would be FFFF. But what's actually connected to the CPU is I have 000 to 003F connecting the bottom of the stack to the top of the stack. I have 0040 to 007F connecting the base of RAM to the top of RAM. Then my base of MMIO is obviously the same base as what I said was actually there. And then, like, but the top doesn't reach the full top. And memory mapped output and memory mapped input share the same addresses. The only thing that changes was whether you're doing a load word or a store word, and that determines if you're on the output or input port. Right? If you're loading a word, then you're loading it from the input port. But if you're storing a word, then you're storing it to the output port. So that's how it knew, like, which one to do. Like, that's the whole nice. That's why you do memory mapped IOs, because you treat it like RAM addresses. It makes expandability really easy. But like that's and then yeah, of course, like the whole point of this thing is like there's pointers, like the like in the Jaller and then jump register ops. You can see I'm either selecting jump in link from well, the link register is RD, but then I'm telling it where to jump from, either as a register value or an immediate. So it can be a pointer or an immediate. Same with jump and jump register. It can be a pointer or an immediate. Which means, and then also in my load store, it's a pointer or an immediate. Oh, actually, no, I'm sorry, it's not even that. It's always a pointer. So the way load store works, for instance, if I find a example set of codes hanging around here somewhere. Here we go. I'll just zoom in on it right now. So you can see here I have store word, frame pointer. Alright, so I'm storing the word at the frame from the frame pointer to the stack 4 indexes in. So basically it's taking the stack pointer register, adding 4 to that, and then storing what the frame pointer is into the stack pointer. So this is how I'm keeping track of subroutines, right? So what is this doing? Like so this is the C++ program. You take A and you take integer A, you take integer B, and you return A plus B, right? You're just adding it, but it's a function. So you can call that function from main. To do that, you need to reserve the amount of memory in RAM required to store all those all those variables to the stack. So I'm taking the stack pointer and I'm saving it -8. So I'm reserving 8 words for it. Then I'm storing the frame pointer to the stack pointer 4 words ahead. Then I'm moving the stack pointer to the frame pointer. Then I'm storing the words in register 4, 5, and 5 at 8 past the frame pointer and 12 past the frame pointer. Then I'm loading in some other words from the frame pointer. That's how you pass register. So 3 and 2 are arguments 0 and 1 registers, where 4 and 5 are saved registers where they get written back. So like there's a calling convention for all this that you would use. And for instance, here's the calling convention right here. So A0, A1, S0, S1, A0s, or all those, any registers with an A are like function arguments. So if I zoom out here again, control minus, and I show you, right here's the register map. So the way the registers are laid out in IntelliRed is, so R0 always returns 0. AT is reserved for the assembler as, for a pseudo op. So if you have a pseudo op that needs to, like, that the assembler will generate, so such as you're taking add and you're making increment, and maybe you need a temporary register that only the assembler knows exists, but like it's not available to the programmer, then that's kind of what that is. V0 and V1 are your two. You can return 2 values per subroutine, and those values are returned in either V0 or V1. You can pass up to 4 values into a subroutine at a time, which are A0, A1, A2, and A3. So you can see if I write A0 in the code, it actually translates to register 4, but if I write A3 in the code, it translates to register 7. So the assembler takes care of converting all those user named registers to like their absolute value. Then, for instance, I have temporary registers, which may be overwritten by a called procedure. So you call a procedure, and it doesn't push this into the stack, and instead it just starts writing over these because it's a scratch pad. Versus the saved registers are not overwritten by called procedures. So if you wanted to save these, the caller had to save these. Versus these are always saved by the callee. Then I have some reserved 2 more reserved registers, and then I have all my pointers. So I have my global pointer, which tells me where in RAM I am, or where in the ROM I'm loading my first code from. I have my stack pointer, which tells me where the stack originates. I have my frame pointer, which tells me what current frame in the stack I'm at, and then my return address register, which tells me like when I enter a subroutine, I store the return address that I want to get to in register 31, called the return address, so that when I'm done in the subroutine, I load the value in register 31, or the return address, to get back to where I started. So originally I only had 16 registers, and I had to compromise, and that made adapting the MIPS instruction set hard. So in IntelliRed, I just gave it the full 32 registers that MIPS has, which this is the exact MIPS register map right there. But I think I'm gonna have to put a lot of thought into now. Well, I have this idea working. So if the program counter is at say 5, let's say program counter here is 5. So the value in this register is the one before that, which would be 4. Then this would be 3. And then here would be instruction 2 being decoded. So if the program counter is currently showing 5, the ROM decoder would be currently decoding the address for instruction 4, while at the same time the ROM is loading the values from instruction 3, while the instruction decoder fetch stage already has the instruction 2 and is decoding it, and then yada yada yada, so on and so forth. So now I need to figure out, I kind of want to get to the data loop here and lay out a data loop, but I'm gonna have to like shop around for like for something that'll do what I want, right? Because like if I want to maintain 5 ticks, the ALU has to be 4 ticks. So this is gonna be, like, if I want this to be a good CPU and not just have fucking 2 registers on it, then this is gonna be hard. But like if you just have like load A and load B registers, and you don't have like a general purpose register file like this, then it becomes super easy, but then a super shit CPU. So like I want a good compromise between speed on the CPU and actual like good user programmability and like good general purpose like design principles built into it. Yeah, but I think I'm going to stop the stream now because there's like a whole bunch of noise in the background, and I don't feel like dealing with it right now. But I'll probably be back on tomorrow and grab the data loop functions that I want, and maybe the easiest way would be like an adder, and then maybe like a set of NOR gates, and then like instead of having to build it into the ALU, which would slow it down or whatever. But then it's going to take 3 cycles to do a subtraction. So I don't know. I have to think about this a lot, and it's kind of a lot of thinking to do off stream. So yeah, thanks for watching, guys. I really appreciate you sticking with me. But I'll see you guys next time.